forgetting, but here we go. All right, so section 4.2, growing functions. So I'm going to give you guys a minute or so, okay, to do the first two columns, okay, growing pattern number 1 and growing pattern number 2. They say for each growing pattern below, study the pattern, draw figure 4, in other words, the fourth part of this, okay, and then complete the chart at the very bottom of the graph, resulting in ordered pairs. Now, if you don't want to do the table, that's okay, but at least draw me what the next one would look like. If this is the first 3 right here, draw the next one, and then as well for pattern 2, don't worry about doing this one, because this one had the fourth one has 256 dots in that column, so I don't need you guys to do 256 dots. But do the first and the second columns. Okay, I'm going to pause this real quick while you guys do that. I'll give you about a minute and a half. All right, so just to show you this for pattern number 1, okay, so the growth pattern number 1, notice if you, on the first one it has 1 dot, on the second one it's 2 by 2, right? It's 2 dots across, 2 dots down, and they fill it in. The third one is 3 dots down, 3 dots across, so the fourth one should look like what? 4 across, right, and 4 down. So we're just going to kind of draw that in there really quick. So 1, 2, 3, 4. 1, 2, 3, 4, and then just kind of fill it in, and there you go. Okay, so it should look something like that. So they tell us to fill out the table. So by filling out the table, I need to figure out a numerical value to put in there. So for the first one, there was 1 dot, and for the second one, there's 4 dots. The third one has a total of 9 dots, and the fourth one has 16. Right, there's a total of 16 dots. So I'm going to go down to the very bottom really quick. And they said figure number 1 had 1 dot, and the second one had 4, and the next one had 9, and the one after that had 16. How many do you think the fifth one had? It had 25, because this should be a square that's 5 across and 5 down, right? So 25. What about 6? 36, and 10 should be 100, and this next one I think is 10,000, isn't it? No, 1,000, sorry. I counted too much. Yeah, 1,000. Okay? What kind of formula is that? It's a square, right? Using 2, right? So n squared. Now, there's a way for us to figure this out, but we're going to talk about that in a bit, all right? Now, if you look at the next one, notice how the next one has like these little patterns, right? So it has a squares with, like the first one is just 1, right? But the next one is a 2 by 2 square, but twice, right? The next one is a 3 by 3 square 3 different times, right? So how many squares is the fourth one going to have? So the third, yeah, 4, right? Because this has 3, this one has 2. This one's going to have 4 different squares, right? So I'm going to kind of do this. 1, 2, 3, 4. And how many dots are going to be in that one? 4 by 4, so 16 in each one, right? So there's going to be 16 dots in each one. So this is kind of the way I do it. When I try to find patterns, I try to show the pattern like in some kind of shape. That way it's easier for me to see it. So I see like little squares, so I make them into small squares. By the way, your homework is nothing like this, which is kind of nice. Okay, you're not going to have to be drawing dots or anything. It's a lot easier than this, okay? Now, how many total dots? Let's see. On the first one, there's 1. And on the second one, there's 8. Okay? On the next one, well, that's 27. Okay, because it's 3 by 3, that's 9 3 times. So 9 times 3 is 27. And then on the fourth one, there's 16 dots 4 times. So that's 64. Right? So we're at 64 now. So let's go down to the table and write this down. So 1, 8, 27, 64. For 5, does anybody know what it's going to look like in turn? 125, right? 125. And for 6? 216, right? So what are you doing to the number? By itself, how many times? 3 times, right? So it's a cubic, right? Cubic power. It's just going to be n to the third power. Now, just so you know, the 10 is 1,000 and the 100 is 10,000, okay? All right, cool. Now, for the last one, the one that we didn't do, I mean, you kind of see it. Notice the first one has 1, the second one has 4 squares, okay, of 2 by 2s. The third one has 9 squares of 3 by 3s, right? So, I mean, you can kind of see it all right here. So I'm expecting the fourth one to have 16 squares of 4 by 4s. Okay, that's 256 dots. Okay, I'm not really trying to do that. All right, so that's 1. On the first one, this is 16 total dots. This is 81 total dots. This will be 256 total dots for the fourth one. So let me write that down. I'm pretty sure you can probably guess what the next function is supposed to be, since the first one was n squared, the next one was n cubed, so the next one has to be n to the fourth, right? So it's a quartic function, right? Quartic function. Let me write it down here. So we have 1, 16, 81, we said 256, 625, 1296, then 10,000, and the last one is 100 million. Okay. By the way, you will notice I have some of these numbers already pre-done. I know that there's a lot of calculations, so I just kind of did them so we don't slow this down. Okay. Sometimes one of the worst things in a math lesson is watching your teacher or waiting for a student to calculate something on a calculator, right? So it's kind of nice just when you see the solution pop up there. If we have to do the work, we'll do it, but we don't have to. So we're done with page 1, kind of. We will revisit, but we filled out everything that we had to do, okay, according to the instructions on page 1. Now let's go over to page 2. So this is just kind of like an FYI type of thing, okay? So they say if you think about growing pattern 1, the function was an n squared, which we call a quadratic function. List 2 things that you know about quadratic functions. Well, number 1, the functions have a highest power of 2. That's one thing I know about quadratic functions, right? The highest power on them is a 2. That's why they call them quadratic, right? Or squares. The second thing that I know about them, that's important to know about them, is that they look like U's. Okay? So they look like the letter U on graphs. Sometimes an upside down U, but they look like the letter U on graphs. So those are 2 things for you guys that you should know. Whenever you see a graph that looks like a U shape or upside down U shape, you should say, oh, that's quadratic. Or if you ever given an equation and you see that the highest power is 2, you should say that's a quadratic equation. That's a quadratic function. Okay? Now, the next one says n to the third is an example of a cubic function. Where do you think the word cubic came from? Okay, it came from cubes, okay, from things that look like this, and cubes have a length, a width, and a height, right? They have 3 dimensions to them. So a cubic function has to do with the 3-dimensional math you have to do. So where did it come from? We're going to say cubes are 3-dimensional. Okay, so usually you have to multiply 3 numbers together, right? Or you got to multiply 3 types of measurements, a foot times a foot times a foot. We call it a cubic foot, right? So it comes from cubes, and it's because they're three-dimensional, 3 things that are multiplying themselves out, okay? Remember, the formula for cubes is length times width times height, but they're all the same, so it's basically length cubed, right? It's the same thing. And the last one is kind of a funky question. I don't even know why they asked us this, but they said for n to the 4th, we call that a quartic function. And I think this question's kind of, I think they just made this up because they had nothing else to ask. Compare the words quadratic and quartic. How many letters are they different? Well, there's the D is different here, and the A is different there compared to the other one, right? So if you get rid of the A and the D, they both say quartic. So there's 2 letters that are different. Again, how does that help me with math? Don't know. I think they just made this question up. All right? So anyway, that was a weird ask, but here we go. Let's go to the part that helps us understand these functions. So the very first thing that they said is none of the 3 functions above was linear. So the n squared function, if I can go back really quick to this thing here, I'm going to draw them for you guys. A quadratic function normally looks like this. A cubic function normally looks like this. And a quartic function normally looks like that. Okay? Quadratic normally looks like a U shape. Cubics, people call them snakes. And then the quartics usually like W's, okay, or upside down W's or M's, right? So they usually look at that. Those are not lines. Those are curves. We call them curves. Lines are straight lines, okay? They don't move around. They're just going straight, okay? So they say none of the 3 functions above was linear, like I showed you guys. What is the defining characteristic of a linear function? Okay, let's answer that first. A linear function is a straight line. Okay, if you look at the root word from the word linear, right? The root word is line. So linear means line. Okay? So to answer the first part, they say, what's one of the main characteristics? Well, it's a straight line. Then they say, how can you tell if a table of values that was made is a linear function? So how can you tell that if they gave you, let's say over here in the very beginning, 1, 4, 9, 16, 25, 36, if they tell you, is that linear? How can you tell? Okay? So the way you can tell is that the y values will change in a constant manner. All right? So I'm going to put right here, the y values change in a constant manner. So in other words, let's say your y values were 1, 3, 5, 7, 9, 11, 13. They were changing by 2 every single time. Then that's constant, which means that makes that table a representation of a linear function. Okay? So if they change by the same number over and over and over again, the y values, then it's a constant. Then it's a linear function. So that's how we can tell if it's linear based on a table of values. Check to see if it's always the same value every time. Now, here's the part that you guys need to know for your homework, and it's not terrible, okay? It's not that difficult. And I already did most of the calculations, so you guys don't have to worry about bringing out your calculator here. But we're going to learn about what's called first differences, second differences, third differences on a table, okay? So right now you'll see what that means. So number 2 says, find the differences between the first 6 function values of f of n, the first chart, okay? The quadratic function. In the table on page 1, describe the pattern you see in those differences. So here we go. We're going to go back up. Remember I told you we were done with page 1, but not entirely. So here we go. The first 6. Now you're going to notice I draw like these little arrows. Okay? I put 1 on 1 and 4, and then 4 and 9, and then 9 and 16, 16, 25, and 25, 36. They said only the first 6, so I went 1, 2, 3, 4, 5, 6. Okay? They want me to find the difference between these. So 4 minus 1 is 3. By the way, I'm going to label this first up here, okay? 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. And 25 minus 16 is 9. And 36 minus 25 is 11. Okay? All right, great. I did what they told me to do in question number 2. They said subtract the first 6 values. What do they want me to do with it? They said, find the difference between those 6 values. Describe the pattern you see. What kind of numbers are they? Those are odds, right? I noticed that they're odd numbers, right? They differ by how much? Yeah, they differ by plus 2, I'm going to put, okay? So you always got to keep adding 2. But are all the numbers the same, though? When I subtracted, do they come out to be the same number over and over again? No, right? So, okay. So now it says show the second differences. Okay, and they say what's the common difference? So second differences means they want you to go back. I'm going to write second now. It's important you guys write the title of it, okay? What do I get when I subtract 5 minus 3 and 7 minus 5 and 9 minus 7 and 11 minus 9? 2, right? And 2 and 2 and 2. Now when you get that, okay, this is important. When you get that, then the title of that is the power of your function. So it's a second power because they all matched. So once your numbers match, that tells you the power of the function. Does that make sense? Okay, so we did subtraction the first time and we got 3, 5, 7, 9, 11. They didn't match. I did subtraction of those numbers and I got 2, 2, 2, and 2. Well, those match. So that means that the function should be a second power. And just like we did, we wrote it down right here, right? N squared. Okay, so if they were to give you a table, you should be able to figure out if it's a first power function, second power, third power, fourth power. If it's a fourth power function, how many subtractions am I going to do? So notice, how many did it take for me to get a second power function? I did subtraction 2 times, right? So if it's a fourth power, how many should I expect to do? 4, right? So let's move on here. Let's go back really quick before we jump the gun here. So question 3, they say show the difference. What is the common difference? It was a, whoops, I'm using a highlighter. It was a 2, right? That's what I got. 2, 2, 2, 2. Okay. They say, hey, do the same thing for the middle column. Do the first and second differences for the middle column. So I'm going to go back to page 1 and I'm going to subtract. Okay, so I'm going to subtract these. I already have the answers from, okay? So if you can, just follow along here. So 8 minus 1, this is my first, okay? Is 7. And 27 minus, oops, yeah. So that's going to be 19. And then the next one is 37. And the next one's 61. And the last one is 91. Okay, when you subtract them. Those are not the same. So I go on to the second set. Okay. So when I do the second set, 19 minus 7, that's 12, and 37 minus 19, that's 18, and then 61 minus 37 is 24, and then 91 minus 61, 30. But those don't match either, which is good because if they would have matched, then my original function would have been wrong, right? I needed to be a third power, so that means this next one should work. So let's do the next one. I know they didn't tell me to do it, but they're going to ask us to do it soon. So let's just do it. The third difference, okay? Third difference. 18 minus 12 is 6. 24 minus 18 is 6. 30 minus 24 is also 6. So all those numbers match, right? All of those numbers match. So once they match, that means that the power for this function is a third power. Because that's where they matched. Third power. So it would be n to the third. So let's go back to page 2. Okay. Go back to page 2 and let's answer their questions. They say find the first and second differences between the first 6 functions for g of n. What do you observe? Well, within the first 2, the numbers, or I guess I could call them differences, so I'm going to write differences, don't match. That's what I noticed. Then they say show the third difference. What is the common difference? 6. Right? We found it. It was 6 for the third difference. All right. So then they ask us this question. What can you make up about what you might find when looking at the differences for the third function, the quadratic? So what are you expecting to happen when you try to find that it's a quadratic function? Well, we kind of mentioned it earlier. How many differences am I going to do? So I'm going to take 4. So I'm going to say I will have to take, or have to find the fourth differences. And at 4, they should match. And right now they're going to want us to show that, okay? Because 7 says, investigate the differences and describe your findings. At what stage do the differences become constant, okay? I'm going to put right now, 4th stage. But let's go do the work, okay? So for number 7, we're going to put 4th stage, because that's when it's going to happen. We already know that. But let's go back and write down all the information. Your homework for today, guys, is going to be doing what we're doing right here 5 times. Okay. It might be a square, it might be a cube, it might be a fourth, it might be a fifth. Okay. I don't think it goes higher than that. But here we go. Let's do this really quick, because I'm not trying to waste a lot of your time with this, because if I can do this quick enough for you guys, you'll have enough time to finish your homework in class. Okay, and that way you don't have to worry about taking home anything. So, like I said, I did this for you guys here. Here is the first differences. Okay, so we're going to get 15, 65, 175, 369, and 671. Those are my first differences. Now, they don't match. I know some of you guys have to go for sports. If you want to go now, go ahead. But they don't match. So, second differences. So I only got to do 4 of them. Okay? Good luck, guys. We got 50, 110, 194, and 302. Also doesn't match. So, okay, it doesn't match. Let me go again. So, 110 minus 50, that's 60. 194 minus 110, that's 84. And 302 minus 194, that's 108. Those don't match, and that's my third, which is okay, because I'm expecting this to be a 4th degree. That means I got to do it 4 times, right? So here we go. Last one. 4th. Well, 84 minus 60 is 24, and 108 minus 84 is 24. Now we got to match. So it happens on the 4th stage, because it's a 4th degree polynomial, right? 3rd degree polynomial happens on the 3rd stage. 2nd degree polynomial happens on the 2nd one, right? Linear functions, or you can call them 1st degree, happens right away. Okay? So, let's go back really quick so we can finish this off. It says, where were we at? I'm on the wrong page here. We figured out the stage, and now we just have to answer question 8. And this part, by the way, you guys can just cancel that out, okay? But it says, what difference does it take to get linear functions? You're going to write first difference. If you get the same numbers after you subtract the first time, then that means it's linear. Well, quadratics are the second one. Cubics are the third difference. And quartic are the fourth difference. If it's a power of 5, then you have to do 5 subtractions total. Okay? It's helpful to have calculators. I'm going to bring those out right now over here for you guys. But notice your homework, okay? Just so you guys know, actually, you only have 4 problems because we found out that this one doesn't work. I think the person who made this did not look at it. They put some stuff together. They didn't pay attention that the fact that these were not increasing by 1. They were increasing by 5s. So, unfortunately, it doesn't give us good data. So you're just doing 1, 2, 3, and 5. Notice number 5. I don't even know what that sign is, but this is number 5. Okay. So what your homework is going to be, they tell you to determine the degree of the polynomial by finite differences. Okay. In other words, do your subtraction. And when you do the subtraction, once you find out when it did it, let's say it took 3 differences, then just put 3rd degree polynomial, 2nd degree polynomial. Or you can say degree of 2, degree of 3, degree of 4. Okay? But that's all you guys have to do.